Hi everyone, I'm Dan, and I work at Thread. More about that in a second. So, just a quick intro to this talk. This is mostly targeted at people who are new to Django, or people who maybe only worked on smaller Django code bases. This isn't about scaling to large traffic volumes. It's about scaling your code bases and how you write your code to work on larger teams or sort of, bigger code bases. If you want to look at the volume stuff, go and look at blog posts from Instagram and discuss. They've got some great stuff on it. So for beginners or people who are used to smaller Django code bases, I'm hoping you'll take away a rough structure of how to structure your Django apps, Django sites as you grow. For intermediate developers or people who are on medium-sized code bases, I'm hoping you'll learn some practical ideas that you can apply to your code bases. And for experts, you probably all know this already, so maybe you'll hear pros and cons of another way. Right, so really quickly, who works on a Django site running in production? Awesome. Who has a code style guide?
Sorry?
A style guide. Who has a style guide in their team? Great. Who has a style guide specific to Django and how they use Django as a team? Fewer. Okay. Who has more than 10 Django apps in their code in their site? Okay. Who has more than 100? Cool. Right. So a little bit about Thread. We're an online personal styling service. We're essentially a completely curated online clothes shop. So our Django site includes e-commerce with a lot of personalization, payment and delivery integrations, a CRM-like system for our stylists, warehouse management, order and supplier management, loads of reporting. We do heavy. We use A/B tests heavily, so lots of reporting around that, and loads of web scraping and processes for cleaning up data. So our code base is mostly one Django site. 364 first-party applications when I counted this about a month ago. We've added more since then. Only 368 first-party models, though, which may give you a bit of a hint of the direction I'm going with this. This is, as I said, this is not any third-party Django apps that we've installed from PyCon or anything. We've got 147 management commands, over 1,000 URL comps, only 65 lines of code per file on average, and that's excluding our migrations tests, I think, and like empty init.pys. And yeah, in total it's about 135,000 lines of Python and about another 60k lines of Django templates. So the first thing I want to talk about is apps in Django. So this is as distinct from a site. A site is built on multiple apps. Django documentation describes apps as a web application that does something. And there are things like an advanced tutorial on how to write reusable apps. They say reusability matters. And I think from this it's really easy to take away the fact that maybe I'm writing a web application, so I'm writing one app, right? Or maybe apps are only for people who are publishing open source libraries for other people to use. I'd say you're making one Django site, but you should definitely have multiple apps. Why? Well, I think apps are great for separation of concerns. When you have an app doing just one thing and you nest your apps according to the domain that they're working on, it makes it very easy to navigate a large project. As I said, we've got 364 apps, I think, and they are nested. We've only got about 20 at the top level, and that means that as you go down, you can find exactly the little bit of the code that you need to work on. And then when you're working on that, you only need to really keep that one app in your head while you're writing the code. And it might only be a couple of hundred lines of code. I think they're great for rapid development. It's easy to find where new code should live, especially if you're writing an A/B test that you might throw away in a few weeks or a few months. You can contain that, and dropping the code might be as easy as just deleting a folder and removing a line from your installed apps list. And really, I think this is the best part of Django. I think it sets Django apart from things like Rails. In Rails, things are grouped, code is grouped by the type of code that it is, a controller or a model or things like that. Whereas in Django, it's grouped by domain. The apps sort of contain all the code required for one particular domain of your code base. So there are some potential downsides. First one that I hear from people a lot is, what about circular imports? Surely with all these apps you're just importing, you've got circular references all over the place. In practice, this is actually quite rare in our code base, we found. We tend to reach up the hierarchy in the app tree, or out to, but only to other top-level apps that contain like the really core models of our site. It needs a little discipline to manage this, but it is completely possible to get around circular imports. The other part is, the other thing I get asked is, what about the global namespace of models? As you may know, you can reference all models by the app name and the model name, for example, auth.user, and that is a requirement in Django. There are a couple of ways to get around this. You can either just prefix some of your app names with the parent app name as well. It doesn't look very pretty, it's not ideal, but that has worked for a very long time, and our code base dates back to about 5 years ago, so this is what we've gone with. The other way you can do this is by using app configs, where I believe you can specify the app name that you want to use, so that the Python package name doesn't have to encode that tree, but the app name can. So, a quick example. So our top-level app is called StyleMeet. It actually predates the name Thread, which is handy because Thread is a bit of an overloaded term in programming. Under this we've got top-level apps. This isn't all of them, but some examples. And these contain like the really core models, things like order or item. They're unlikely to change ever. But these are huge, or would be huge, so we start to nest things underneath. Things like stock levels is an app that just tracks the stock levels of items. It only imports up into inventory to get a reference to the item model, and it just has a simple view, like one URL conf, I think. Might have a form for filtering that view to a date range, but it's really straightforward and very easy to hold the whole thing in your head. Then we've got larger subsystems, again, within inventory. We've got a review process where we clean up the data from our web scraping. And so we start nesting even further with each of the stages of our review process coming in under there. As you can see, these are prefixed with inventory review because some of these might be names that we may want to reuse elsewhere. They, again, only import up to inventory review, maybe up to inventory. Inventory review will contain all the models required for that review process. Yeah, we can then isolate these stages of review, and it means that we can create new stages or drop old stages, or just work on one stage and keep it all in our heads at one time. In practice, we don't tend to nest much further than this. I think we've got 4 fourth-level apps, and they're very, very specific. So this tends to get most of the benefits. So yeah, the rule of thumb is divide now. When you're making new features, make a new app from the beginning, because it's easier to merge apps together than it is to separate them later on down the line. So, next thing, let's talk about the internals of apps. Django has this pretty figured out for the basics. We've got all the basic files that you'd expect, and these are really pretty well defined. We've then got a couple of others, things like tasks, if you're using something like Celery or another task queue, and then there are some more uncommon ones that Django has. It's very easy when you're writing code in an app to sort of maybe want to extract a 2-line util function or something like that, and think, oh, I'll just stick it in my models.py next to my models. That's fine, right? And it is when you've got a handful of apps, when you've got a handful of models, that's not a problem. But as you get bigger, it is going to become more difficult when you come onto an app that maybe you've never seen before or you haven't touched in 6 months. It's going to be more difficult to find where that code is. So I would encourage you to start specializing. Start finding the things, the files that make sense in your project. We use an API.py to define the public API that other apps are allowed to call. We define all our enums in one place. We have some systems here that do auto-discovery of metrics, of reports, of sitemaps, so that apps can easily define their own sitemaps, and an auto-discovery mechanism will pick that up and integrate it into the global system. And really, once you've sort of figured out these things that you reuse throughout many apps, you end up with very little that doesn't have a defined place. Unfortunately, there are still a few things that do end up in the utils.py, But by the time you've extracted all this other stuff out, utils.py for us is very often reusable business logic, and so even utils.py is fairly obvious what will go in there, even though it is a little bit of a catch-all kind of name. So, moving on, let's talk about naming things. It's really important, as I'm sure you can imagine, to have a consistent style for naming things in a large project. Being able to effectively grep your code base is really important, particularly when you've got like 100,000 plus lines of code. Being able to find every usage of a particular thing is really important. So our Python and Django style guides favour consistency. I'd encourage you to find a naming scheme that works all the way from URL names through to views, your template hierarchy, your app names, and your module names. We have a pretty consistent style with this, so it means if I'm in a view, I can probably guess what the template's going to be called, what the URL name is going to be, and so on and so forth. And this really does help. I'd also encourage you to do the same thing with models. Name your models, decide whether you're going to include the app name in the model name, for example. Define a style for how you name your relations or your fields. Do your related name, do all of your models need to have a related name, or do you use the underscore set names that are auto-generated by Django? We define related names for everything, and we have some style around that, and fields as well. I'll give you an example of the field name in a second. And another one, use named URLs everywhere. This is critical to being able to grab the code base effectively for all usages of a particular view, things like that. Make sure you name the URLs so that it's easy to find them. Here's an example of a model with some field names. It's entirely reasonable to write a blog post model that has an author field and a published field. This would make complete sense in the case of a blog post. But user and created are much more generic names that you can apply to many, many more models. And when you're joining onto this table from 3 joins deep from the other side of your code base, predicting what these fields were called on this model can be a real pain. So having consistent naming of the user field or the created field or other things that you might have in your code base is really beneficial. And there's one example where I think the consistency is worth more than the fact that this looks a little bit better for a blog post. So next up, let's talk about models. Relational databases are great. I think it's worth getting the design right up front and trying to encode as much domain knowledge into your models as possible. That means getting the uniqueness constraints right. Django has unique together. If you haven't seen it, it's a way of combining multiple fields so that you can get the right constraints. And there are lots of other ways to help you model the domain you're working in. And I really encourage you to try and encode as much as that into your models because it helps with maintenance in the long run. Django migrations are great, but don't import things in them. Django migrations are about the time that you generate them, not about the time that you run them. You might run a migration months and months later when you're trying to rebuild a database or something like that. So I would encourage you to copy stuff in. It may seem a little bit counterintuitive. You want to import and reuse things, but copy in constants, name them, give them a comment saying where they came from, and then the underlying code in the rest of your project can change, and that's fine because that's normal. You want that to be changing, but migrations are fixed in time, and that helps. You don't really want to be maintaining old migrations that you wrote 6 months ago. We avoid signals and we avoid overriding save. I think we've got 3 signals in our code base across 360 odd models. There are always going to be exceptions to the rule, but they basically just make it difficult to know what is happening when you're saving a model or changing a model, and it can lead to performance issues and things like that. So we tend to avoid them, particularly for business logic. We'd rather wrap up the core parts of that business logic into an API that explicitly does the steps rather than relying on signals to kind of link together all these different side effects. And keep models small. We have a lot of models that are like 1 or 2 fields. It's very easy to end up with like a profile object that has 100 fields on it. But by splitting that out and having lots of small modules, you can be more fine-grained with your caching. You can also locate those models next to all the other code that deals with those models in the apps that are specific to those models. We have a model called dress code, I think. It hangs off auth user. It's got 1 field, which is the user's dress code. But it sits with the other code that deals with that model, and it means that we don't have another field that would end up on a profile. So Django Auto One-to-One is a really handy little library for automatically creating those submodels. So I think one of the best bits of Django is the architecture it defines for you, but it's not perfect. And sometimes when conforming to that sort of view model kind of structure, things just don't fit in sometimes. So I started learning Django on version 1.1 from a book called The Definitive Guide to Django. Some of you may remember it. And I pretty much only remember one thing from it, and that was that Django is just Python. It repeated it loads of times, and it kept really sort of hammering this home. So what I took away from this is when the Django architecture isn't fitting, don't be afraid to create your own architectures. There are things that don't fit into the Django world, so leave that behind. Create a Python package that maybe isn't a Django app, and make a well-defined API into the Django world, and you'll hopefully end up with something that's easier to understand, build, and maintain. So there you may end up with bits of business logic in views. Maybe when it's just 20 lines, that's fine, but if you end up with 100 lines or more in a view, you might want to extract that out. It makes it easier to extract out into a library later if you ever wanted to do that. But also there are some other things you can do here. You could separate it from the database, which might make it faster to test. So an example of this is we have about 500 lines of business logic to select which tips to show to users. This is tips about dressing well. And this is a completely self-contained module that's completely separate to Django in our codebase. And essentially the API takes named tuples. We construct those out of the Django models. But because that API is then separated from the database, it's very easy to test, and it's also completely deterministic. We don't have to worry about any sort of side effects that it might be doing out in the rest of the system. Django also has the pattern of backends. You may have seen this with database backends and cache backends. I would encourage you to create your own where it makes sense. You may have a task backend for a queuing system, or SMS backend, or a payments backend, or in our case, a recommendations backend. And by extracting these things out, it makes it really easy to swap in different implementations in different situations. So in local development, you might back onto Stripe's test API rather than their production API, so that you can test making payments locally. And the last example of this is don't be afraid to just go and build entire subsystems that are pretty much isolated from Django. They can maybe import the models if they need to. We tend to use management commands as a nice entry point to this. So we've got a scraping subsystem within that that's, I think, about 15,000 lines of code. So it's really quite large, and it's pretty much entirely separate from Django. It defines an API that we actually have contractors work to. So yeah, we're able to share the work there of maintaining our scrapers through that well-defined API. The last thing I want to talk about is testing. Write tests that write themselves. This may seem a bit weird, but we've got a number of checks, a number of tests that we wrote a very long time ago that are still expanding and serving us well now. Things like testing to make sure that when you import a Python file, it doesn't make any database queries. or testing to make sure that every HTML file in our codebase can be parsed as a Django template. These, you only have to write them once, but they will keep scaling up as your codebase grows. These ones are kind of handy, but they're mostly just sort of sanity checks. I think this is more interesting when you start writing these for bits of your own projects that make sense. So we do a lot of A/B testing on our registration funnel, the way that users sign up to Thread. There are a number of steps in this, and we A/B test a lot. So we've developed a test for all of our funnels that it will programmatically create and run through each of the funnels. So every time we add a new funnel, we get a suite of tests for that for free, essentially. We do the same with checkout. We have a number of different types of user, and we can run each type of user through our checkout system and check that at the end they've managed to place an order and things like that. So I would encourage you to write tests that will grow automatically as your codebase grows in certain ways. And the other thing here that we do a lot of is custom assertions. So there's lots of assertions built into unit tests, and obviously you can write them for PyTest if you're using PyTest. But unit test provides things for assertions for working with the standard library, but Django adds a few for working with Django types. We have added even more. We've got things like assert sent email, or assert sent SMS, or assert enqueued task. And these are really valuable. I don't think that many people really enjoy writing tests. I think a lot of people kind of do it as a little bit of a chore. So making your life easier means you end up writing more tests. You end up writing better tests that assert more about the correctness of your system. So by writing these little bits of tooling to help you, I think it really pays off. And again, I would encourage you to find the places where it makes sense in your project specifically. We've got one in our warehouse system, assert barcode scanned successfully. It's like 10 lines of code, but it's 10 lines of code that contains some great assertions that really check the validity of the system at that current time. And we now use that assertion probably 50 times in our test code base. And so it saved us a lot of time and made our tests a lot stricter. So, to summarize, make more apps. Apps should do really just one thing, the smallest little unit of functionality, I think. Be consistent. That's code formatting, it's naming, it's the way you use Django, the Django APIs that you use. Try and automate as much of that as you can, maybe through linters, but have a style guide, not just for Python, but for Django as well, or for how you use Git or CSS or whatever. Consistency is, at least for us, and I think in general, consistency is almost always more important than the reasons for going against it in any one case. Follow Django patterns. Create your own backends. Create your own class-based view hierarchies. If you have mixins that you use a lot, do that. Create your own test utilities and assertions. And remember, it's just Python. So when it doesn't fit, don't force things into the Python, the Django architecture. Set that aside. Build something in Python that works really well, and then figure out how to make a nice API to call into that. And yeah, not everything here that I've spoken about will apply to every code base, so evaluate it in the context of your code bases. Find what works for you, but stick to it, and be strict and have a strong opinion, because that will serve you really well as your code base grows. So, thanks for listening. And Thread is hiring. We do a lot of Django. We're a fairly small engineering team of just 8, but we deploy changes up to 40 times a day, and we have a strong focus on culture, transparency. We try to minimize office politics and really maximize the impact of our developers and everyone in the company. I'll be around outside to talk about any of this stuff, any of scaling Django and Thread. Thank you.